Question number 1 from Monday night's homework is 5x squared plus 17x plus 6. So we have a trinomial, and traditionally when we have a trinomial, most times we're factoring it back into two binomials. So to do that, we have to first make sure we do not have any common factors between 5, 17, and 6. There's not a common factor that I can pull out, so I'm going to begin factoring. So since the leading coefficient is greater than 1, there are two routes that I can take. There is guess and check, or the slide and multiply, factor, divide, bottoms up. So we'll do this guess and check, and then I'll remind you what the slide, divide, bottoms up method looks like. So guess and check, I need to set up my two binomials, think of the factors that multiply to give me the beginning term and the factors that multiply to give me the end term, and then I'm going to use that to see which combination adds to give me this middle term. So factors for 5, well 5 is prime, so my only options are 5 and 1. For 6, I've got 2 times 3 or 6 times 1. So I'm going to have a 5x and a 1x at the beginning, and I know that has to be the combination. So now I have to try these two combinations for the other piece. So if I really have a number sense here, I know that 5 times 3 gives me 15, and then another 2 is 17. So I'm going to try this combination with the 2 being here and the 3 being here. Since the 6 is positive, I know these signs had to match, and since it adds up to a positive 17, I know that they're going to need to both be plus. So to check this out, I would have 5x times x is 5x squared, 2 times 3 is 6, and I'm really having to check the middle. 5x times 3 is 15x, plus 2 times x is 2x, which gives us the 17x in the middle. So these are indeed the factors. I could have written the factors backwards, but the 5x has to be with the 2, and the 1x has to be with the 3. So if you didn't want to do guess and check and you liked the little trick that we learned before, the way we did it is we took the leading coefficient and multiplied it by the end coefficient. So we would have x squared plus 17x plus 30. And then we would try and factor like normal. So we know that this was x and x. So then I would only be focusing on the factors of 30 that add up to 17, and I know that's 15 times 2. I know that they both need to be positive, but when I do this method I have to remember to go back and divide by what we multiplied by. So divide by 5, divide by 5. Reduce if it reduces, so 15 divided by 5 is 3, so I've got x plus 3. 2 over 5 doesn't reduce, so this is when the bottom goes up front, and this would be 5x plus 2. So those are both ways that you could have worked number 1. Number 2 is another one with a leading coefficient greater than 1. Between 4, 33, and 8, there's not a common factor. So I can do the slide, divide, bottoms up method if I would like. I would have to multiply 4 times 8, and I'd have x squared minus 33x plus 32. Factor, x squared came from x and x. 32 combinations, there are multiple ones, but I already see that if I need it to add up to 33, it's going to be 32 times 1. The signs match, but this tells me that both of them must have been negative. So I'm not done, because this is the special trick method where I have to always remember to go back and divide by the leading coefficient. Got to divide both of these by 4. So 32 divided by 4, that's going to give us x minus 8 here. Then 1/4 doesn't reduce, so the 4 goes up front, and we've got 4x minus 1. The other way you could have done it is guess and check by focusing on the factors of 4 and the factors of 8 and seeing which combination multiplied out to give you the 33. Question number 3. Okay, so this way there are technically two methods of factoring this. I could leave it as is and try and factor, or I could see that since all three terms are negative, they technically share a -1 GCF. Okay, so multiple routes here. I'm going to do it both ways. If I were to pull out a -1 first, that's going to change the signs of all three terms. Between 5, 48, and 27, nothing else can be taken out. So I've got 5x squared minus 48x, plus, and plus 27. I would leave that -1 outside and try to factor what's inside. So I could either do this 5 times the 27 and factor like we did on the previous one, or I can do guess and check. I'm going to do guess and check this way because I'm just trying to mix up methods for you so you can get comfortable with all of them. So if I do guess and check here, I'm going to look at the factors of 5 that multiply and the factors of 27 that multiply to give us 27. 5 is prime, so the only combination is 5 and 1, so I'm going to go ahead and put 5x and 1x. 27, there's a couple different combinations. I could have 27 times 1 and 9 times 3. So I'm kind of looking at 48 to help me decide which one I should use. I already am thinking if this is 5, 5 times 9 is 45. So I'm going to do this 3-9 combination first. This tells me both signs match. This tells me both signs were positive. So let me check this out and see if it foils back out to the beginning problem. So the -1 is outside. I would have 5x times x is 5x squared. 5x times 9 is plus 45x. 3 times x is plus 3x. 3 times 9 is 27. And when I combine like terms in the middle, it does go back to 48x. So this whole piece here would be part of your answer if you decided to pull out the -1 first. Now, technically, I could factor it without doing that. I would use, if I got -5x squared minus 48x minus 27, I would have to keep in mind that when I do the factors of -5, it could either be a 5 times -1 or a -5 times a +1. When I do the factors of -27, it could be 9 times 3. One of the 9 could be negative, or the 3 could be negative. And we also had 27 times 1, but we know it's 9 and 3 from the previous version. So I'm going to try it with a -5x and a +1x. And then I'm going to try it with a +9 and a -3. So in order to check it out, I got to FOIL it back out. I've got -5x times x is -5x squared. -5 times +9 is a -45. -3 times a +x is a -3x. And a -3 times a +9 is a -27. So -5x squared, -27, and our middle, -45 minus 3 gives us -48x. So these would be our factors if we hadn't pulled out the negative. And it's really just because this -5x minus 3 has a GCF of -1 as well. So both of those are the answer. A lot of times teachers will make you pull out the negative first because it is technically the GCF. Alright, number 4, again, leading coefficient greater than 1. There's only 3 pieces, so I know I'm more than likely trying to put it back into 2 binomials. I could slide, divide, factor, all that good stuff, so we'll try that one. We'll do both ways here. So if I do the trick and I slide 6 down to 20, I'm going to have x squared minus 7x minus 120. The two factors that I'm looking at are some numbers that multiply to give me a -120. So I've got 10 times 12, obviously 60 times 2, but I'm looking for something with a difference of 7. So I'm probably thinking more around the realms of 15 times 8, because I know 15 and 8 have a difference of 7. So I know that the signs have to be different and that the larger number is going to end up being negative because this comes out to be negative. So I've got x and x. 120, I'm going to do the 15 times 8. And then I'm going to make the 15 the negative, because if I do that, that'll give me -15x plus 8x, which gives me the difference of -7x. Remember, if I do this trick, I have to always go back and divide by that leading coefficient So I'm going to divide both pieces by 6, and here I have to be careful because I have to reduce. X minus 15 over 6 comes out to be 5 halves. X plus 8 over 6 comes out to be x plus 4 thirds. And still, since they're both fractions, I have to do bottoms up and put the bottom up front. So we'd have 2x minus 5 times 3x plus 4. And that should fall back out. We've got 6x squared. That gives me a negative 20. So the middle is a negative 15 plus 8, which is negative 7. That works out. So the other way would have just been to guess and check. So I know I need to focus on the factors of 6. So we got 2 times 3, or 6 times 1. Then I focus on the factors of negative 20. I've got 5 and 4, 10 and 2, and 20 and 1, and I know that I could have to do both versions because it's negative. I could do negative 5 and a positive 4, and I could do negative 10 and a positive 2, negative 20, positive 7. You just got to consider all alternatives. So I am going to try the 2 times 3 first, 2x times 3x. And since I know I have to have a difference, I already know that the signs have to be different. I'm thinking 2 times what and 3 times what. So I'm probably going to use the 5-4 combination. So let's just say I use 5 here and 4 here. I am going to have 8x and 15x, and I need the 7 to be negative. So I need to know the 15x has to be the negative, and the 8x has to be the positive. So when I fold it back out, I already proved that it works. That's going to give me 6x squared minus 15x plus 8x minus 20, and this middle term comes out to be minus 7x. Number 5, factor completely. So this time we have more than 3 terms. This is 4 terms. So more than likely, unless they all share a really obvious GCF, this is probably going to be factor by grouping. So I'm going to group together the first 2 terms, group together the second 2 terms, and you always really want to have a plus in the middle unless you're pulling a negative out from the second parentheses. So before you start pulling out GCFs, kind of if there's a minus there, shove it in with the front term and put a plus in between. So in this first parentheses between 6 and 16, they're both even numbers. 2 goes into both of them. V cubed and V squared, we can take out at least a V to the second power. That leaves us with 3V minus 8. Then 21V minus 56. 7 goes into both of those, so plus a 7. When we pull that out, we've got 3V minus 8. So we're not done because both of these binomials now match, and they are a factor that we need to factor out to put out front. So we would have 3v minus 8. And when they are factored out, what we are left with is the 2v squared plus 7. So you could have written this factor first, but everything else has to be the same. Alright, so on this example, 4 terms again, I'm going to factor by grouping, so I'm going to group together the first 2, and I can't just do this and put that negative between it because that negative's not being distributed to both things. It only belongs to that 105. So really what I've got to do is I've got to keep the negative with the 105 and put a plus sign between these 2 parentheses. Between 63 and 54, I know that 9 go into both of them. N cubed and n squared, I can take out an n squared. So 63 divided by 9 is 7. N cubed over n squared would leave us with n. 54 divided by 9 is going to leave us with 6. N squared over n squared is gone. So from a negative 105 and a negative 90, we can take out a negative 15, and that would leave us with a positive 105 divided by 15, positive 7, n. Negative 90 divided by negative 15 is a positive 6. So once again, because our binomials match, they are a common term to factor out. We will factor out 7n plus 6. We will be left with 9n squared minus 15. Final question, factor completely. So this is only 3 terms, but it's not like just a v squared or v4 kind of thing. It's not where I'm going to break it down into 2 binomials. I see that I need to pull out a GCF first. So between 30, 36, and 12, I know that 6 goes into all 3 of them. So I could take out 6. Then I've got v to the 5th, v to the 5th, v to the 6th. I can take out at least a v to the 5th. And then this first term is the only one with a u, so I can't take out any u's. So when I take out 6v to the 5th, I'm really like dividing all of the terms by the common factor to find what's left. That would leave us with 5, v to the 5th is gone, u cubed. 36 divided by 6 is going to be 6, v to the 5th over v to the 5th is gone. And then 12 divided by 6 is going to leave us with 2. V to the 6th divided by v to the 5th leaves us with v to the first power. Now, if you wanted to, you could technically rearrange this to put your u cubed, 2v, and 6, but since we're really focused on the GCF part of this, we're not going to stress out too much about it. You would always want to check what's left inside to see if it can be factored, but 5u to the 3rd plus 6 plus 2v, a u to the 3rd power like this isn't going to be factored back into 2 binomials. You can factor things to the 3rd power, but you will do more of that in Algebra 2.